Hey everybody, Brian Laborde for episode 3B, I should say, of my Cockpit Refurbish, which is the other half of my panel lift kit. Again, this is ASW-20 Model A, my Bravo Lima aircraft, and I'll put links to the other videos of all the work that I've done in the description in case you want to jump back. This is the link to the Part A version of this, which goes through all the CAD work and sort of the design side. This video is really going to focus on the pieces, the assembly, and then the final outcome. So I hope you enjoy it. In the prior video, I went through the CAD work, so I'm not really going to go much into the design. I do want to talk really quick about the parts, the materials that we used, and the assembly process. So there's only 10 pieces to this. The 10 printed pieces, I should say, 10 design pieces. Then there's the screws and the carbon fiber tube. The pieces are this block here, which is I call the main block, and then the horn. And these two are mirrored on either side. So when you 3D print them, you mirror them in the system. And the rest of the parts, which are the cross straight adapter here, the middle adapter, and the lift block, you just print two of each and they work on both sides. So all of these were printed out of a material called PAHTCF, which is a carbon fiber filled nylon material that is very heat resistant. Essentially, it's the material that is under the hood of your car for all of the plastic parts. Very high performance. It's amazing that you can print it. It is a pain to print, and this is the material. As you can see, it's not the cheapest material, but it is extremely strong and rigid, and it's made for outdoor, high temperature, UV resistance, etc. It does require annealing to get the full strength out of it, which just means you stick it in your oven for 8 hours at 200 degrees, which I did for all of these parts. And then you get the full strength out of the material. So once I had them printed, I just got the main blocks installed, which there's on the main blocks here, you can see there's two screws on the top and there's one screw in the bottom. Those three screws go into riv nuts, which I drilled and embedded into the side of the underneath the canopy, which there's a hollow area. Of course, you don't want riv nuts sticking out of your airplane, and it held it fantastic. You can see there's a curve on the back side of here, which was designed in. I did have to do some sanding on this to make it fit as tight as I wanted, but as long as it was contacting the top and the bottom, where it gave it a really stable surface to pivot on or to bind to, then it was fine. And once I got it in place, it was rock solid. I did create a subassembly. So basically this piece, which in this adapter piece is glued in this tube, was done first. Then I came back and this cross straight tube, I glued in 180 degrees to this piece. Then I came back and this lift piece is the only one that is sort of a compound. Once I got the glue on it and got it in place, I pushed it into position using the horn adapter, and that gave me an offset to the position here. And then I had it set on my bench where this was completely vertical, and I had a protractor set to where it was a 20-degree incline on this, and it put 20 degrees on that. That's important because it allows for the full motion without this lift mechanism binding. If you're too far down or too far up, it winds up hitting. So having that 20 degrees in place is important. Once I had that and I got all of this into the aircraft, I put these two tubes in with these pieces on loose, not glued in, and made sure that I had a little bit of wiggle room of sliding these back and forth in those parts. I needed to trim these tubes just a hair bit to make sure that I had that room, so that when I assembled this, which was I put the panel on, and again, this isn't glued in place yet. I just put the panel on and had it sitting there. I didn't have the nitrogen springs in at that point. and I put glue on the two outer pieces, put the tube in place, and then put glue on these and put a screw here, and then let it set given the position and the spacing and everything that is within the aircraft. So doing this cross tube last gave me a lot of more flexibility to adjust for the actual conditions in the airplane. And then the last step was coming in and gluing the panel on. So I put the nitrogen springs, everything in place, put the two horns in with epoxy in there, and then I dropped the panel on. I didn't tighten them really tight. I got everything aligned and rotating these pieces in before I tightened it, and then let it cure in that position. So the panel, it was in place, and when it cured, its final cure, and it works absolutely great. One more thing I want to point out. So this bottom cover, I did design and print. Now I printed it using this material here, and most people print with a PLA on 3D printers, and I happened to print some little tool bins with it and left it on a bench that it got hit by the sun for a day, and it turned into a pretzel. PLA is terrible if you're going to have it in any heat or any outdoor, and this material here is not that much more expensive. It's roughly the same price, and it's much easier. It's much better outside. Outdoor ready. It's fairly resilient. It's not as strong as the PAHT, but it's absolutely great for this application. And just to give you an idea, this is what it looks like for a 3D printer to print a part. This is clearly a time-lapse photo, and I think the entire duration was roughly 9 hours to print these pieces, but you just start it, let it print, and it goes through, and you have a part that comes out at the end, which, from an old-school engineer, it's truly amazing that you can buy something that you have in your house and you can 3D print parts. So back to the drawing here. This is the fully assembled model of what it looks like, and I'm going to jump to the airplane and show you what that looks like in position. But very easy installation. It was not nearly as bad as I expected it to be. And this is the final product. It is gorgeous. It works exactly as I hoped. You don't even notice it when the panel's down. The lifting doesn't take a lot of force, just a couple pounds to push it up, and it pops up out of your way. And honestly, just a little pull pulls it right back down, and stays down just as I hoped it would be. Looking around at the backside, again, my design was really to make sure I don't have to replumb it. I didn't have to replumb it, and all of the pieces that I designed out of the PA-HT material, carbon fiber, are working absolutely great. Carbon tube, everything is holding up. No problems with those materials, stresses on them or anything. Looking at the mounting bracket, you can see the 3 mounting points. It's holding in just perfect. No issues. It doesn't want to move. It is rock solid. You can almost move the aircraft with one of those, that they're so solid. I did design these custom guides for both the tubes and the wires to help it pivot right without, catching anything or binding. And again, the design is so that the pivot and the wires are right near the pivot point, so they don't pull very much. In fact, you can see that they barely move. If I get down a little bit lower, you'll see that those wires are not pulled almost at all. Again, I didn't rewire any of this. Everything is exactly as it was before I started. The safety question that I had mentioned earlier, a standard panel lift kit mounts to that bracket, and that's great, but it does put the panel very high up here, which is okay, but it does require a lot more wiring, etc. From the safety perspective, when you do have to eject, you're going to pull the release that will get rid of the canopy, and that bracket will wind up coming down and come down harder into this area. and hold your panel in place much more rigidly than it would be normally because the canopy isn't there. I wanted to design something that when that bracket is down and it's in that position, when the canopy's gone, the panel can lift up and operate freely without being impeded by that bracket and being attached to it, and allowing me to get in or out in that situation much easier. Now, I hope to never try this or have to use it, but that was part of my design criteria. I want to talk a second about the bottom cover. You saw this being printed on the 3D printer. Again, it's made of that PETG material. While not structural, it works perfect for this, handles the UV absolutely well. It handles the heat absolutely well. I had to print it into 2 pieces that are assembled along that seam along the bottom that you see, but put the fasteners in so I can take it on and off whenever I needed to, and it truly makes the panel much more professional. Now, when the panel was down rigid, you would never see the wires, but when the panel does come up, you could see through this whole area, and it would have really looked terrible if I hadn't have covered it up. Now, this is where I started, and oh my goodness, what a journey to get to where I am, and I just can't believe it's been a little while, but here's where I'm ending up, and it looks fabulous. I plan on doing a few more things to it, and I'll have some more videos of some little parts that I'm designing and printing and putting in the cockpit. But, for the most part, this is the major redo. And hope you enjoyed it. Thanks for watching. If you have any questions, leave them in the comments. I'll try and answer everything that you guys ask. And fly safe.